All right, so area of regular polygons. In this example right here, we've got a regular hexagon. This has 6 sides. You can see they're all 16s. It's a little story behind it is that Megan is painting the floor of her gazebo. So this is the shape of her gazebo right here. And the floor is the shape of a regular hexagon with sides that are 16 feet in length. Find out how much paint is needed, meaning we need to find the area of the stuff inside of it. Now, when we did triangle, when we did trapezoid, I showed you how you could duplicate them and turn it into a parallelogram. We doubled the triangle, we flipped it over, we set it next to it, and we could make it into a parallelogram. Well, the same is kind of true here. If you look inside this triangle, or this hexagon, you've got a triangle right here. In hexagon, if it's a regular hexagon, that's going to be an equilateral triangle in every regular hexagon. But if I was to duplicate that and turn it sideways a little bit, since it's equilateral, I can put it like this. And I can make that into a parallelogram with 2 of them. But inside, how many triangles do you think we would have inside of the hexagon? There'd be 6 of them. So I could take and duplicate these. That would be 4. And duplicate it again, that would be 6.
Wait, that's what you
I'm going to show you how you get the formula here. So every hexagon right here could be broken up into a parallelogram. You could take all 6 of these triangles out, shape them like this, and you would have a base times height parallelogram. Now, how would I find the base here? How much is the base? If I added these up, I would have 1, 2, 48. I'd have 3 of them, right?
48.
48 is right. Now, if I would have had, that would be 3 of my sides. How many sides are there all together?
6.
So basically, my base is half of my perimeter. Because all the way around would be 6, and I only want 3 of them for the base, right? My height is the height of my parallelogram. So the formula then is basically going to be to take half of my perimeter and times it by the height. So let me show you what that means. Now, in polygons, we have a different name for the height. The height is actually called the apothem. It's another word for height, and it's in a regular polygon. It's from the center to the edge at a 90-degree angle. It's not the center to a letter. If I'm going from the center to a letter, then you would call it the radius. The radius is like a circle. If you made a circle around this, it would touch all the letters. That's the radius of the polygon. But the apothem is from the center to the edge. And we also have central angles inside. A central angle is an angle that's made from the center, and if you go all the way around, you'd have 360 degrees of central angle. So your area of any regular polygon can be found by taking the triangles out and making them into like a parallelogram. And the formula then is to take your apothem and your perimeter and to cut it in half. Multiply your apothem times your perimeter, because remember, we only need half of the perimeter. To get this base, we just needed half of my P right here. So I take the 1/2 times, and I multiply it by the area, or the apothem and the perimeter, and I get my area of a regular polygon. The key word here is regular polygons. These only work for regular polygons. It doesn't work for just a pentagon that's got weird shapes, weird sizes. Only works for a regular pentagon, which would have all 5 sides and all 5 angles the same. It only works for a regular hexagon where all 6 sides and all 6 angles are the same. So it's this formula, and it's very easy to find. You need your apothem and you need your perimeter. Once you've got these two, apothem and perimeter, you can find your area. Now let me go to an example. Here's a regular pentagon. Now this one's a little tougher because they didn't give us the apothem or a side. They gave us a radius of 1. So the radius is 1, And if you notice, all of these angles in here are 72 degrees because 360 total degrees divided by 5 different angles would give me 72 degrees. And if I cut this one in half, that's going to make two 36-degree angles. 36 and 36 would be my 72 degrees in there. Now the reason I did that is because I want to bring out a right triangle. It's got a hypotenuse of 1, it's got a 36-degree angle. And I need to find the apothem, because to find the area of this regular pentagon, I need to use this formula, 1/2 times the apothem times the perimeter. 1/2 times the apothem times the perimeter. So, how do I find the A? How do I find A? I've got a right triangle. What works for every right triangle? Pythagorean theorem and SOHCAHTOA. You could use either one. In this case, SOHCAHTOA would be better because you have an angle. So here's my adjacent side. Here's my hypotenuse. Adjacent hypotenuse. Do I use SOHCAH or TOA? C-A-H. I have the A and I have the H. Cosine of 36 equals the adjacent side over the hypotenuse. In this case, it's A over 1. Well, if I multiply by 1 on both sides, it's really not going to change anything. So 1 times the cosine of 36, I believe, is 0.81. If you double check it on your calculators, cosine of 36, I believe, is 0.808, which would be 0.81. That's my apothem. So my area equals 1/2 times 0.81, and I don't know the perimeter yet. I still need to find perimeter. Very distracting. All right, we need to find perimeter. So to get perimeter, I need to find this x right here. Or this x down here, you might say. What do I use to get that little x? I could use Pythagorean theorem. I think it's easier, though, to use SOHCAHTOA, because this time I have the opposite side and my hypotenuse, OH. SOH for sine. Sine of 36 equals x over 1. If I just multiply by 1, all I need to do to put in my calculator is the sine of 36. You put in the sine of 36, you get 0.59 for your x. So this bottom piece down here is 0.59. But I need the whole bottom piece.
Is that 30?
36. So if I have 0.59 right here, how do I get the entire bottom piece? Double it. You're going to get 1.18. So this bottom piece is 1.18. And if I want the perimeter, I multiply it by 5, which gives me 5.9 for equals my perimeter. So 5.9 up here. So you're going to need a calculator. You multiply the 0.81 times 0.5 times 5.9. Multiply those three together. 5.9 times 0.5 times 0.81. You get 2.39 when you round it off. So your area equals 2.39 square units. Okay, a flat tent top has the shape of a regular pentagon. So you could, regular pentagon, and it says the sides are 15. It says the apothem is 10.3. So our area equals 1/2 times the A times the P. 1/2 times the apothem times the perimeter. So 1/2 times 10.3. And the perimeter would be 15 times 5 sides, which is 75. So your P, to get the perimeter, you just multiply 15 times 5. There's 5 sides of 15 each. So you're going to do 1/2 times 10.3 times 75. You get your area would be 386.25. And that's square feet. So this time they made it a lot easier. They gave us the apothem. They gave us a side so we could find the perimeter quickly. This 15 was a side, you just multiply by 5 to get perimeter. And they gave you the apothem of 10.3. So you could just plug those straight into your formula, and you have your area of that regular pentagon. Okay, we just have a couple of practice ones to do on the other side. They're pretty easy. The first one is a square, and the second one is a regular hexagon, and then the bottom one has a little bit of a twist to it. That should be pretty easy. So take a look at the square. In the square, they gave you the apothem. Now, normally, for area of a square, we would just use side squared. That would be our normal area of a square. The new area formula that you can use is because a square is a regular polygon, you could also use this formula. Now, if they give you the side, just plug in side squared and you get your area. It's really fast. If they give you the apothem and you maybe want to plug it into that and solve it, it works the same. Just want to show you that it works on both ways. So put in a line here. And what did I just make? I made a special right triangle. And it is a 45, 45, 90. Yes. Apothem is from the center to the edge. So it has to be halfway. Yes. So the center has to be in the middle. So what do I know about this 45, 45, 90 triangle? What do I know about the two legs? The two legs are what? Congruent. So this has to also be 3.5. So what does that tell me about my side of my square? The side of the whole square is how much? How much is it? Yeah, 3.5 times 2, you get your side. Yes, and now in my first formula, you get 7 squared, which is 49. So that makes it easier right there. You get 7 squared, which is 49. If I was to plug it into the other formula, I would put area equals 1/2. My apothem was 3.5. My perimeter is how much in that square? What's my perimeter? 7 plus 7 plus 7 plus 7. 7 times 4 is 28. So you multiply all these together, and you would still get 49. Either way, you're going to get 49 square inches. Both of them give you the same. Now, if you come to the regular hexagon, you need to use this formula because it is a regular polygon. You must use the 1/2 times the apothem times perimeter. They give us the apothem, so let's get started by plugging in the apothem. 1/2 times 2.8. They don't give us the perimeter. That we need to plug in. Okay, so we need to plug in the perimeter. What did they give us, though? They gave us the side length. And what do we know about this regular hexagon? Is that all 6 sides are equal. So that means they're all 3.23s. So if I multiply that by 6, you get 19.38. So 19.38 would be your perimeter. Now you can just multiply 1/2 times the 2.8 times the 19.38. 0.5 times 2.8 times 19.38, and you get 27.13. And that would be square centimeters. So area of your regular hexagon. Just use this formula. If they give you the apothem and the side, Then just find the perimeter real quick, and you'll have your area of your regular shape, regular polygon. Okay, the last one has a little twist to it because it's a square and a regular octagon together. It's a square and it's got a regular octagon on the inside of the square here. Now the first one says, what is the length of one side of the octagon?
Oh.
Okay, so, well, let's look what we got down here. We got 24 at the bottom. And we want to know what this piece is right there. 24 minus 14.06. 24 minus 14.06. And you're actually going to get like 9.94, I believe. 9.94 would be this piece right here. Okay, that is the side of my octagon. Now, what is the perimeter then of my octagon? 9.94 times?
Oh, 9.
Times how many sides? 8 sides. So 9.94 times 8 sides. You get how much? 9 times 8 is 72, right? So 9.94 times 8 sides, 79.52. Okay, so that's going to be the perimeter, and that's in inches. Now, letter C up here. What is the length of the apothem? So, from the center to the edge. You could go this way, you could go this way if you want to, you can go over here, you can go straight down. From the center to the edge in a square is the same no matter which way you go. And how long do you think our apothem is here?
12.
Has to be 12. Yeah, it's got to be half of 24. It's got to be 24 divided by 2, which is going to give us 12. So 12 inches is our apothem. So what's the area of the octagon? Area equals 1/2 times the apothem, which is 12, times the perimeter, which we found down here in letter B, 79.52. Okay, so 477.12 square inches. That's the area of the octagon, just the octagon. That's the white part. Now the last question down here, letter E, says what's the area of now the shaded part? I need to take my entire square and subtract out the octagon. And that will give me the shaded part. So the square minus the octagon gives me the shaded part. The square is 576. How did I get that number? 24 times 24, 24 squared. Minus the 477 that we just found. What is the area of my shaded part? Somebody on their calculator get it already? 98.88 is right. And that would be square inches. That's your shaded part for area. All right, so those are regular polygons.